the way this little line here for the unloader valve connects to the bottom of the old pressure switch is through this weird fitting. This fitting sits in here, and there was a grub screw that I took out, basically retains it. But it's kind of, this hose goes in the bottom. There's this plastic retainer ring almost. But if I take the retainer ring off, I can't pull this hose out of here. So I don't know how the heck they put that together. This end is more conventional. It's got, you know, the little ferrule, and it's got the nut that would crush that down into there. And, you know, the reality is I don't even know why I'm bothering and wasting time with this. It's a more conventional fitting on this end of the new pressure switch too. So this hose is going to be plenty long enough. I might as well just cut this off and stop screwing around with it. Just because I was so curious, I decided to yank on this thing with a pair of pliers, and I was able to pull that little piece of tubing out. And I can look down inside there, and I can see what looks like it's a spring-loaded check valve, this assembly. There's a hole here to vent. So this is interesting to me. I'm not sure how this works. I'm hoping whatever job this does is built into the new pressure switch. Okay, so I needed a 3/4 inch to 3/8 reduction bushing, and unfortunately I couldn't find one. So what I ended up getting was a 3/4 inch to 1/2 inch reduction bushing, and then a 1/2 inch to 3/8 reduction bushing. And I'll have to put the two of those together. And then I got a close nipple 3/8 so that I can keep this. I want to keep this check valve as close, mounted as close to here as possible, because that's going to help with my alignment here with the pipe. So I'm ready to put this part all together. So I'm going to get some thread sealant and goop these up good. All right, so I got this part done. So now I'm just going to hold this line, just about even with where I want it to be able to meet up. I've got a little bit of fudge factor here because I can bend this a little bit to suit my needs. And I'm just going to take a Sharpie and mark a line. So I'm going to cut that tube there and then reflare it. Grab a tubing cutter. Well, the memory card on the camera filled up, and I don't want to quit working on the thing, so I've been working on it, and then I went up and had supper and unloaded the memory card. So started to locate the holes there and drill them. And when I first punched the holes locations, I was getting ready to drill them, and then I realized that there's these bars in the bottom get in the way. So unfortunately, if I were to have the bolt heads here, there's not enough clearance there, I don't think, for a bolt head. So I relocated it. I think looks like I'll be able to rebend that copper line and just enough to shift the whole thing over. So now I'm drilling the first two holes here. Now some of you may remember that between this base plate and the mounting plate on the old Hitachi base, there were these rubber washers, and they're supposed to try and isolate some of the vibration, and they were pretty rough. So what I did was I didn't have any rubber thick enough that I could use to cut anything out of. So what I did, I just cut 4 little donuts out of the scrap of hose left over, and I'm going to use those. I'm going to stick those in between the plate and the base, and as the bolt will go through them and keep them from being able to just fall out, and it should give me a little bit of that shock absorption that I'm looking for. Alright, so I had already played around with how I was going to orient this pressure switch, and I quickly realized that I wasn't going to be able to just put it straight onto this nipple like this for a couple of reasons. The first problem is, well, let's start by looking at the switch. There's 1, 2, 3, 4 ports. All 4 of these ports basically just go right into the body of the switch. There's nothing unique about where these ports all go. But what is unique about the ports is that there is a smaller orifice for this port, this port, this port. This port is wide open. This is the port that's supposed to be on the nipple going to the tank. Now, I'm not sure whether or not it would be detrimental to hook up the nipple to the side one here. It is different, like I said. There's actually down inside there, you can actually see that the hole is much smaller. There's actually it's a partially blocked opening by design for some reason. So I gotta believe they did that for a good reason. So I'm gonna do what their probably original intention was, which is have this nipple go to this port on the bottom, whereas these ones with the restrictions on them are ones for output, ones for the pressure gauge of the pressure in the tank, and ones for the safety release, the overpressure automatic release there. So if I were to put this on like this, well, one of the problems I have right off the bat is now my button to turn this on and off when this cover's on is in a really hard place to get at. So I don't like that. I could have my emergency blow off on the bottom here, my gauge right here on the top where it would be easy to read, and my output right here. So other than that, that actually works. So I'm tempted to maybe still do it that way, even though I already purchased an elbow with the intention of actually installing that elbow. So let's see if we did it like this. Does that improve things? That actually takes the switch further down. Up on top here would be, well, that wouldn't be too bad, would it? You know, the other thing too is it wouldn't be so bad except for the fact that this darn button is so hard to actuate. I mean, it's ridiculously hard to pull. Okay? See how hard I have to... Turning it off's a little easy, but turning it on... I mean, I wish I could quantify that for you, how difficult that is. So I'm looking at this and I'm wondering, why is this so hard? So the way that this button works is this button's got like a an unusual shape, and there is a row of plastic fingers in a circular fashion arranged around the outside of the button. And what happens is when you pull up on this button to turn it on, those fingers have to spread apart. So my feeling is, if I put a light coating of grease on this red part of the plastic here, I think that would make a world of difference. That's just a theory. I don't want to use oil because the oil won't stay. The grease might actually stick around for a little while. So let me try that. Alright guys, it's the next morning, and what I did last night before I went to bed, I'm not sure whether or not I videoed it or not, but I hooked up the unloader valve. I installed the switch the way that I think I'm going to go with. I just temporarily put in the gauge here. The gauge has a very small fitting, so I had to, I needed a reduction bushing for that. Luckily, there was a reduction bushing that was removable in the old pressure switch. So before you throw out your old pressure switch, if you took the gauge off, make sure you get this bushing with it. Otherwise, you'll be finding yourself making a trip to the hardware store and buying an expensive little brass bushing. So anyways, so I decided that, yeah, I'm going to go with using the short nipple, putting it on this way. I was able to route the unloader line and have it wrap around and come up. Now, I could have cut it shorter, but if I did that, the line actually would have to make a very sharp turn right here. And I actually think this is better for it to have kind of a long sweep as it goes in. Might be overthinking that, but no harm in that. Don't have this screwed on yet, but let's just check how our button's doing this morning. That's definitely easier than it was yesterday. So I think my my grease idea is working. I'm getting ready to start doing some of the electrical hookup here, and I rotated the switch upward a little bit so I can get better light on it, get a better look at it with the camera, because I wanted to talk about how this works, because it's kind of interesting. The cheapo El Cheapo pressure switch comes in a box with absolutely no paperwork, and there's absolutely nothing on the box explaining how to wire it. So they just figure that you're going to intuitively know how to do this. So obviously, you know, this is something that if you're not comfortable working around electricity, you shouldn't be attempting to undertake. And anything you do regarding this, you do so at your own risk. But I'll just talk about how this basically works. There are two screw terminals on the top here and two screw terminals on the bottom. The screw terminals are marked behind on the brass plate, or actually it's not brass plate, on the metal plate behind it. There is an N, then there's a line, and then a P. It's almost like a fraction where N is the numerator and P is the denominator. So the N appears to correspond to this top screw, and the P tends to correspond to the bottom screw. Now maybe N is for neutral, and then what's P for? Power? Not quite sure. Now maybe this is, again, maybe this goes to some kind of a weird European type of thing. I don't know. I'm sure somebody who's watching this video will probably chime in if they do know, because previous commenters have already set me straight on this color coding that I wasn't used to seeing, where the yellow with the green stripe is indeed the ground, but the brown and the blue apparently are common for neutral and hot colors in the European electrical arena, as opposed to here in the US, we tend to go with white for the neutral and black for the hot and solid green for the ground. So anyways, getting back to this, I tend to think, well, N for neutral and P for the hot. But the other thing that kind of interests me is there is a small white dot of paint that has been placed closer to this bottom screw marked P. So that little white dot would make me think, oh, they want the neutral going there, because it's common practice in the electrical field. My understanding is it's common practice to, when you have those rare situations where you need to run a non-white colored wire that's going to act as a neutral, maybe part of the time or all of the time, like maybe in a three-way or a four-way switch situation, that the electrician will mark the end of that wire with some white tape or white paint or something to indicate that that is in fact acting as a neutral. So the little white dot of paint might mean nothing at all, or it might mean that they intended for us to use this screw as the neutral. I'm not going to worry too much about it, because looking at the design of the switch, there appears to be absolutely nothing different from this set of contacts to this set of contacts. So the way this works is, it doesn't apparently matter which side you put the load on, which is going to the motor, and which side you put the line on, which is coming from the cord. There's nothing to indicate a difference here. Sometimes with a relay or some types of switches, you will have that clearly marked line and load because they want the power coming in on one side and going out on another side. This does not appear to suffer from that. The design of this switch is so basic. We've got this lever on the top here, which runs down and actually is tied into the pressure switch. This lever on the top here, because it's spring-loaded, it constantly wants to be up, which is keeping these contacts right here that I just opened by pushing down on this lever closed. Okay? So by default, when this cover is off, when this plastic cover is off, this switch is always on. What shuts the compressor off completely, believe it or not, is just the act of screwing this cover on, because then this switch from hell that I was talking about, okay, actually pushes down. So you want to turn the compressor on, you pull this knob, now that allows this to pop up and the contacts close and the compressor runs. When the compressor reaches pressure, the air pressure overcomes the force of a spring and cam inside here and then forces this lever to pop down and shut off. As you use air and the pressure drops to a certain preset level, this will snap back up, close the contacts, and the compressor will restart, hopefully. So, how does this work? Well, power comes in from one wire. It comes in on one of these screws, okay, goes through this metal plate to this contact here. When this is in the on position, this contact and this contact make. This is just a metal bar that goes through this plastic piece over to here, through this closed contact and out. So essentially what we've got is we've got two contacts that are closing. This is a series circuit with two switches or contacts in series. Okay? So you get two contacts in series. So power flows in through here, through here, through here, out to this screw here. And then your other line, whether it be, if this was the hot and this was the neutral, okay, then your power flows, your power flows through here, goes out to the load, does the work, comes back, and goes back out through here, through here, through here, and back out. Now, if this was a DC circuit, what I just said would be absolutely 100% correct. But because this is an AC circuit, the power is actually going back and forth at, here in the US, a rate of 60 times per second. But now we're getting into an overcomplicated discussion of AC versus DC, and that's for another time and another channel. So, all I need to know is, put two of the wires on here that come in, and two of the wires on here that go out, and Bob's your uncle. All right, so I just want to talk real quick about the strain relief that they use on these cheapo things. I've actually seen this used on some other devices too, air blowers and a couple other things that I've run into over the years. So it's basically, it's got no metal parts whatsoever, and you've got this plastic beveled piece, okay, with slots cut in it. And this works kind of like a collet. What ends up happening is this goes into this hole, and I dropped it. Oh. All right, so it goes up into this hole, and the cable goes through that outside, goes through the hole in the center there, and then this is pushed up and driven into the hole by the tightening of this piece right here. And what that causes is because the hole's got a bevel inside of it, causes these four sides to push in and tighten down on the cable. So it's actually kind of an ingenious design. It's a cheap way for the manufacturer to make this. Alright, so I'm getting ready to put in the new cord on. This is the cord off the old Hitachi, and it's got paint all over it, and I would still reuse it because it's actually in good shape except for one thing. It's missing the grounding prong. Somebody either broke it off intentionally or it just broke off. So I'm not going to reuse this cord and find something else. Well, I went through my scrap wire box where I throw all my cut off cords and everything for scrap. Occasionally I'll go and pull something out of there, and unfortunately all of the cords that I found in there that had three-prong molded plugs on it like this all had the grounds broken off, except for this one. But then I looked at the wire on this one and it looked really thin. I was like, wow, what the heck was this? I don't even remember what I took this off of. Must have been a vacuum cleaner maybe, I don't know. So I just looked out of curiosity, and I could still make out the writing on the cord off the Hitachi compressor, and it was it's 14 gauge wire, 14 AWG. So I was wondering, well, if that's 14, what the heck is this? Turns out this is 18 gauge wire. So 12 gauge wire is generally for 20 amp circuits. 14 gauge wires for 15 amp circuits. So this must have been to run something that was like 10 amps or less. So not much power. So I'm not going to use that. And I actually don't currently have any plug-ins to spare. I only have one extra one, but I've got an extension cord I want to repair. So I'm going to save that for my extension cord. So I'm going to actually put this Hitachi one back on, and then what I'll do later, when I pick up a plug end, I'll cut this off and replace this. But I just want to get this thing up and running.